Okay, hi guys, welcome to section 3.1, Inequalities in their graphs. So this entire chapter and this section relate to inequalities rather than equations like you're used to working with. So first thing I want you to write down, an inequality is a mathematical statement that uses inequality symbols to compare the values of two expressions. So the way that we are going to start this section is by labeling our four inequality symbols and then giving a brief description about what their graphs look like and then their verbal meaning. So if we first look at this pink inequality symbol, the way that I like to think about it, if we get confused, is that we read from left to right, correct? So the left-hand part of this symbol is small. It's less than the other part. So this symbol is a less than symbol. Okay? When we graph this, our graph is an open circle. Just like this, on whatever number it's telling me to be on. Similarly, this green inequality symbol has the larger part first, meaning that it is a greater than symbol. When we graph, we again have an open circle. Okay? Coming down to this yellow inequality symbol, we see a less than sign, just like this pink one, although it has this line on the bottom. This means that it is a less than symbol. Or you see this line, that's half of an equal sign. So it's less than or equal to. That equal to portion of this inequality symbol makes this a closed circle when you graph. Because whatever value you're starting your graph at is or could be equal to that x. So lastly, we see a greater than symbol and we also see this line, so that means that this is a greater than or equal to. And again, this means that it is a closed circle. Okay? Make sure you get this down, and we're going to move on to put this into practice. Okay, next up. So we see these verbal expressions. So what we want to do is create an inequality that represents them. So if we first look at this A, it says all real numbers x less than or equal to negative 7. Less than or equal to is this symbol, correct? And then we're just going to fill in what else we know. It says all real numbers x are less than or equal to negative 7. So what this means is that for every single x value that's less than negative 7, it satisfies this inequality. So some examples would be negative 7 satisfies this inequality, negative 8, negative 9, and all numbers towards negative infinity. Okay? If we jump down to B, it says that 6 less than a number, k, is greater than 13. So we see this less than, and then we also see this greater than. The important part about this is to realize where your is statement is. So this is, similarly to equations, breaks up the equation from the left-hand side to the right-hand side. It does the same thing for inequalities. So wherever you see this is, right after it is going to be the inequality symbol that you are going to record. So it says greater than. So we're going to be using a greater than symbol. And now we want to take a look at this left-hand side and see what I'm going to write. So it says that 6 less than a number, k. So that means 6 less, meaning subtracting 6, from some number k is greater than 13. So as you can see, we use that is in the expression to figure out how to write this inequality statement. It's going to be really important to dissect what it says so that we can record the right inequality statement. Okay? So, next on the agenda is talking about solutions of inequalities. So a solution of an inequality is any number that makes the inequality true. So This next question asks us, are the following numbers solution to the inequality 2x plus 1 is greater than negative 3? So the way that we're going to do this is plug in negative 3 for x and then do the same thing for negative 1. And we're going to see what we get and analyze our solution. So as you can see, 2x, that means that 2 is being multiplied by x. And in this case, my x is negative 3. And then I'm going to rewrite down my entire inequality. So 2 times negative 3 plus 1 is greater than negative 3. And we want to see if this is true. So the way that we're going to do that is just simplify our left-hand side and see if whatever number we get is greater than negative 3. So 2 times negative 3 gives me negative 6 plus 1 greater than negative 3. So negative 6 plus 1 gives me negative 5. Is negative 5 greater than negative 3? It is not. It's actually smaller. So negative 3 is not a solution to this inequality. Okay, great. So we're going to do the same thing for negative 1. So instead of negative 3, we're going to plug in negative 1. So I have 2 times negative 1 plus 1 greater than negative 3. Negative 2 times negative 1 gives me negative 2 plus 1 is greater than negative 3. Negative 2 plus 1 gives me negative 1 is greater than negative 3. And this, in fact, is true. Negative 1 is a larger number than negative 3. So negative 1 is a solution to this inequality. Great. Nice job, guys. Let's move on. So last thing on the agenda for today is to just graph some of these inequalities and see how the meanings and the symbols that we did on the first slide actually play into effect when we're graphing. So n is less than 1. So the first thing I like to do is indicate the number I'm working with. So I'm looking at 1, right? Now this is a less than symbol, which means that I'm working with an open circle. So I'm going to put an open circle at 1. Now, where are the numbers that are less than 1? Because that's what it's talking about. It's everything to the left. So all you're going to do, mine is going to be messy because I'm on the computer, is darken the left-hand side, and it goes on infinitely. So it's important to draw this arrow. Okay? So next up, a is greater than or equal to 0. So you see the difference between this symbol and the symbol up here. This one has this equal sign at the bottom, which means that it's also going to be equal to that number. So we are working with a closed circle, and that closed circle is going to be at 0. So we have a closed circle at 0. Okay? And it says that a is greater than or equal to 0. Well, all my numbers that are greater than 0 are this way. Okay? So next up, f is greater than negative 3. I see negative 3, so I'm working right here. And it is just a greater than symbol, so I'm working with an open circle at negative 3. That is not pretty, but you guys get it. And all the numbers that are greater than negative 3, again, are to the left. I'm sorry, the right. Can't tell my left from right today. So last up, this problem looks a little bit different because my x is on the right-hand side. What I'm going to do is rewrite it. So do you see how this smaller part of the symbol is next to the x? I have to carry that with it. So this becomes x is less than or equal to negative 2. I have to flip everything. So with that being said, this is a less than or equal to symbol, which means a closed circle at negative 2. So which values are less than negative 2? Everything to the left. Okay? Please write down questions that you might have. It's really important to nail this down in section 3.1 rather than go on and not know what's going on. So make sure you write down your questions, and please don't hesitate to ask me in class. Thanks a lot, guys. Have a good night.